if she needs. And we are done with that for now. So now we're going to switch to our measures of dispersion notes. Sorry, I should have left this up. So these notes are linked on Canvas. So if you need to go print it out real quick, feel free. If you don't have a printer, try to follow along and write what you can. And I will post the final copy of this on Canvas and obviously the video so that you can go back and look at it and retake notes. So, okay, so we're talking about measures of dispersion. Measures of dispersion is kind of asking how spread out is the data. Okay. So, let's see. Okay, so we're going to look at something called the variance, which we're going to represent with this little symbol here. I forget what it's called at the moment. And the more, so the more spread out, the larger value we have for variance. That is so ugly. Hold on, let me just, the more spread out data we have, the higher the dispersion is going to be. Okay. So if we have maybe one dispersion value being bigger than another one, okay, this one is going to be more spread. And this one is going to be less spread. Okay. And there is a formula for this that I'll write on the other side of the top. Okay. So the formula for this, the variance is going to be the square root of the sum of all of the differences of each individual value. So we have each individual value, x sub I, minus the mean, mu, squared. And all of that is going to be divided by the total number of elements in the set. Okay. So x sub I is each individual like piece in the data set. Mu is our mean. And then we're squaring the differences, the sum of the differences of those. And then we're dividing all of that by the total number of things that we have. Okay. So for example, in this one, what is my mean going to be? What's my average? 2, 3, 4, 5, 6. So this, what's the sum of all these numbers? Oh man, I put your names back. Those of you who called. Izzy, what's the sum of 2, 3, 4, 5, 6? So 2 plus 3 is
5. I think it's 20.
Another 5 gives me 10. Plus 4 gives me what?
20.
Oh yeah, so the total is 20. We have 5 total things, so that means that my mean should be 4, right? Okay, so we're asking how far are each of these values from the mean value? Okay, so how far are each of the other values from the mean? And so we can calculate this variance. Let's see. Should we just do it, or is there a way to, hold on one second. Okay, so we could just do this by filling it in the formula. And we would be taking, should we do it or should we just do the answer? I think that there's a way to do it on your calculator. I'm just going to tell you the answer for now. And then, so this variance, wait, okay. So hold on. These notes are terrible. I need to redo these notes. I am so sorry, guys. So there is a way to do this in a way faster method. So this thing squared is called the standard deviation. And when you take the square root of that value, you get the variance. The variance you can calculate directly, but it's easier to calculate this number, and we can do it on our calculator, which I happen to have left upstairs. So I'm going to fill these in for now. And maybe in a minute I'll run and get it so that we can go over this together, because this is ridiculous. Okay, so the two sets here, let's look at what they have in common and what they have different from one another. So they both have 5 numbers. They have the same mean. Okay, but the difference is how spread out they are. So these variance values are different. So the differences are how spread out. These go into the negative values and also go up higher. Okay. Let's see. Okay. So let's go through this, and then we'll come back up to this because I did a really terrible job explaining that. So it says to represent the data more accurately, you need the mean plus a measure of spread.
Wait, Miss Roberts?
Yes.
What's the O with the swoopy thing? What is that?
I forget which Greek letter it is. It's a Greek letter. It represents variance.
And what's variance? So
it's
variance.
How spread out the data is.
Okay. Yeah, no, I'm just really confused, what we did at the top.
Yeah, we're gonna come back to this.
Okay.
Ignore this for a second. Okay, we'll come back, I promise. Because all of the bulk of the information is right here, but then they start off with an example. So let me explain it first, and then we'll come back. I'm really sorry. I should have thought about this for a second. Okay, so to represent the data more accurately, you need a mean plus a measure of the spread or dispersion of the data. Okay, one simple measure of dispersion is the range. Okay, so differences in values, which equals the max minus the min. Okay, so just taking the maximum number and subtracting the minimum number from it. Okay, so mean deviation.
Wait.
Yes, Chloe.
So
yes, Chloe.
I'm trying to write this down.
Right. So we're gonna go through this pretty quickly, and then I'm gonna post it at the very end, finalized, so that you can go back and look at it. Okay. So it's gonna be on the screen though. Okay. So the mean of the sum of the squares of the deviations from the mean is what this thing is talking about. So we have the square, or the variance squared. It's called the deviation, or the difference of the values of x from the mean. Okay, which is that guy. Okay, and the variance, which is this weird symbol here without the square, I'm sorry, this is the variance. Okay, is going to be the sum. This is what we wrote up at the very top. The sum of differences between each of the units and the means squared all over n. And this guy is the total number of data points. Okay, so this kind of gives us a little bit of a more direct way to find these values. So we could go back up here And we could take each of the individual values, so like 2 and subtract 4, 3 subtract 4, 4 subtract 4, 5 subtract 4, and 6 subtract 4. Okay, so that's the difference between every single one of the elements in there and the mean, which happened to be 4. We would square each of those. Let me do this on, I'm sorry, let me move this page. I'm gonna just do this on a different sheet of paper because this is like way too much. So we would add 2 minus 4. Is there, you guys can't see the bottom, I'm sorry. I am doing a terrible job today. I'm sorry, I apologize so much. Okay, so here, now you can see the notes, and I'm gonna try not to cover up too much while I write. So 3 minus 4 plus 4 minus 4, 5 minus 4 plus 6 minus 4. And each of those differences would need to be squared. We divide by the total number of things, which is n, or 5 in this case, and figure out what that is, okay? And this thing is equal to our variance. Okay, so 2 minus 4 is 2. Square that, or -2, and when we square that, we get 4. 3 minus 4 is 1. When I square that, -1. When I square that, I get +1. Then we have +0. Then we have +1 again. And then we're going to have +4 again. And we're going to divide all that by 5. So 4 plus 1 is 5. +1 plus 4 is going to give us 10 total. And when we divide that by 5, we should get 2. So that's how we get our variance here. Our deviation is going to be defined as this, just this little guy by itself. Okay. And that's why this guy up here, when we're looking for this, we take the square root because it's just the square root of this value. This value right here is called our variance. This is our deviation. Most of the time we will look at variance. That's the one that they really care about. And you can do this both by hand and on the calculator. Maybe I've done a slightly better job now of explaining it. What questions do you have? I'm sure you have a ton.
I have a question.
Bring it on.
Okay, so in the variance box, the formula that you gave,
Yeah.
I know like X with the line over top of it is the mean, and that N is the total number of data points.
Yes.
What does the other X stand for? Is it just X, or are we supposed to replace it with like a value?
So you would replace it with a value. So that's what like each of these guys were. These were each of the like units in the data set. So 2, 3, 4, 5, and 6 for the first data set.
Okay, so you plug it into each individual one and then add them all together.
Right. That's why up here I have X sub I. This one should probably be X sub I as well. And I should probably use the same variable for mean. Mu is mean, but so is the X with the bar over it, and that's what we use bottom, so we'll stay consistent.
Okay.
Okay, does that help?
Yeah, that helps.
Okay, great. What other questions do you guys have?
Can you move the papers back to the variance box being visible?
Okay, what
I have
other
a
questions do you
question.
guys have?
That little E thing in front of the parentheses, where did that go? Like, is there a value for that in the example that we did?
This means sum. That's a sigma.
Oh,
It means
okay.
to add all the values that are in here together.
Okay.
So that's why when we did this example, we have plus signs between all of those different squared differences that we